3, 2, 1, 0.
August 23rd, 2023, 6:04 pm. Every screen in India was showing the same image, a spacecraft, 370,000 kilometers from the Earth falling towards the moon. A billion people were watching the same thing live. Not just in India, the world was watching. Because 4 days earlier, Russia had tried the same thing. Same target, same location, same geographical area of the moon. They had 60 years of experience in space research, $200 million spacecraft. They crashed. Now in India, with a budget smaller than the film Interstellar itself, had tried something that nobody had ever done before in the entire history of space exploration, landing on the moon's south pole. And here is how they did it. The engineering involved behind this is more incredible than any news headline ever told you before. Stay with me until 8 minutes mark, because I am going to take you to the last 17 minutes of the journey of Chandrayaan step by step in a way that no headline ever told you before. Stay with me. Let me show you a number. 615 crores. That's what Chandrayaan-3 cost. In dollars, $74 million. For a context, the movie Interstellar, Christopher Nolan's movie about space, cost $165 million. 1,368 crores. More than the double. India landed on the moon for less than it cost to make a Hollywood space film. But here is what I want to make you understand. The cost is not the miracle. Cost is just the side effect of the miracle. The real miracle is the engineering behind this. Because to land on the moon, especially on the South Pole, you have to solve a set of problems that are genuinely hard. The problems that China solved, problems that America solved, problems that Soviet Union solved, but none of them could solve the problems on the South Pole. Because to land on the South Pole of the moon, it is quite difficult in comparison to other part of the moon. And to understand why, I want to first take you back to 2019, the night before India's heart broke. September 7, 2019, 1:52 am, Bengaluru, ISRO Mission Control. Hundreds of scientists who had spent years for building Chandrayaan-2 were sitting on the moon and watching a screen. The Vikram lander was 2.1 kilometers away from the moon's surface. It was supposed to land on the next 13 minutes of its journey. The PM Modi was sitting on the room. Hundreds of school children had been invited to watch India's first lunar landing live on the screen. A billion people were watching that on TV screens. Then, the telemetry signal got flattering. The Vikram had gone silent. The room, which had been buzzing with one of the most worst events in Indian history, had completely gone silent. Then, the ISRO's chief K. Sivan walked up to PM Modi and quietly told what had happened. PM Modi put his hand on Sivan's shoulder and cameras caught a single tear on Sivan's eyes, and the image went viral. What went wrong? The engineering failure was quite specific. During your phase called the fine braking phase, when the lander was reducing its speed to land gently, the velocity dropped more than the algorithms had planned for. That deviation meant of the start of the final descent was outside the design parameters. Their onboard computers couldn't recover in time. Vikram crashed 500 meters just where it was supposed to land, 500 meters, after covering a distance of 384,000 kilometers. But here is what happened next. And I think this is the most important part of the story. ISRO did not give up. They spent 4 years for understanding what went wrong. They redesigned their lander, they improved their algorithm, they added more fuel, even they rebuilt their entire guidance system. And in 2023, they tried again. The difference between Chandrayaan-2 and Chandrayaan-3 is a masterclass in engineering problem solving. And I want to show you what exactly they changed because that is genuinely brilliant. ISRO's engineers did something that world's best engineers do after a failure. They asked the right question, not why did we fail? Rather, they asked what have to be true for us to succeed even if everything goes wrong. And this question led to three specific changes in their system: stronger legs, more fuel, and smarter software. The landing on Chandrayaan-2 was designed for a fairly gentle touchdown. In Chandrayaan-3, ISRO strengthened the landing's legs significantly. The lander could now survive a hard landing at 3 meters per second instead of the gentler velocity planned for Chandrayaan-2. In other words, even if the landing wasn't perfect, Vikram wouldn't break. Chandrayaan-2 ran into a trouble partly because their engines had a limited capacity to correct a deviation, while in Chandrayaan-3, ISRO had increased their fuel capacity, which has led for the engines to fire more and correct a bad trajectory in the mid-descent. This is the most significant one. ISRO improved their guidance, navigation, and control algorithms. This new software tells lander what to do at every moment of the descent. And this is the software that is a safety envelope for the whole spacecraft. And it could handle more deviations from the planned path and still find a way to land safely. July 14, 2023, Sriharikota, Andhra Pradesh. The LBM-3 rocket, ISRO's most powerful launch vehicle, lifts out from the Satish Dhawan Space Center. For the next 40 days, the combined spacecraft, propulsion module, lander, and rover will travel 384,000 kilometers to reach the moon. But it doesn't go in a straight line. It can't either. Straight lines in space require enormous fuel. Instead, ISRO uses a beautifully engineered technique. They first orbit Earth, getting higher and higher with each orbit. 5 times they fire the engines to raise the orbit. Then, at the precise right moment, one final burn shoots the spacecraft towards the moon. This is called translunar injection. On August 5, Chandrayaan-3 enters lunar orbit. Then more burns. This time to lower the orbit until the spacecraft is just 100 kilometers above the moon's surface. On August 17, a critical moment, the lander, Vikram, separates from the propulsion module. The propulsion module has done its job. Vikram is now on its own. 2 more braking burns bring Vikram into lower orbit, just 25 kilometers at its closest point above the moon. And then, August 23rd, the day world watches. At 5:47 p.m., the engines fire. The 17 minutes begin, and in those 17 minutes, everything that ISRO had learned in the last 4 years of failure and redesign. It would either work or it wouldn't. There was no second chance. Let me take you inside those last 17 minutes. Here is something that most people don't fully appreciate. Landing on the moon is almost impossibly hard, not because of the distance, that part we can calculate, but the 3 major problems that are stuck on top of each other. No atmosphere, no GPS, no remote control. The moon is 384,000 kilometers away. At the speed of light, a signal from Earth takes 1.3 seconds to reach the moon and 1.3 seconds to come back. That's a 2.6 second round trip in every command. In the final descent, where the lander is falling towards the surface at about 1600 kilometers per hour and every second takes milliseconds. A 2.6 second delay is not just slow, it's fatal. ISRO couldn't control the landing, not at all, not even slightly. Every single decision were taken by Vikram's onboard computer at every point of time, autonomously, alone. 384,000 kilometers from the Earth. Phase 2. Fine braking. Vikram is now 7.4 kilometers above the surface, traveling at 360 kilometers per hour, pointing straight down. The cameras are active. The heads-up detection system is running. Every second, Vikram is taking photos of the ground below and comparing them to the preloaded map. Is this patch of ground safe? Are these boulders? Is there a crater? A slope of too steep to land on? The computer evaluates, decides, and adjusts. The engines continue to fire, but now with much more precision. Variable thrust, throttling up and down in real time to maintain the perfect descent rate. This phase lasts about 3 minutes. During this time, Vickers drops from 7.4 kilometers to 800 meters above the surface. At 800 meters, a brief pause. The altitude hold phase. The Vikram hovers. Take one final look at the ground, confirms its position, confirms the landing state is safe, and then the final phase begins. In the ISRO mission control room in Bangalore, the engineers who had worked for this mission from last 4 years, some of them for decades. Some of them were present in the same room in 2019 when Chandrayaan-2 failed. They were crying, not performing in cameras, not celebrating in the crowd watching, just crying. They had done something that no country had ever done before in the entire history of human civilization. They did it with a budget smaller than a Christopher Nolan's film. Chandrayaan-3 was not the end of India's lunar ambitions. It was the beginning. Chandrayaan-4 is planned to bring back samples from the moon, actual lunar rock returned to Earth. Gaganyaan, India's first crewed spacecraft, will carry Indian astronauts to orbit. Not the moon yet, but orbit first. And in the next decade, ISRO had started its intention to put an Indian astronaut on the moon. For a space agency that had started with scientists cycling rocket parts to the launch pad, carrying them on bicycles because they had no trucks, this trajectory is nothing short of extraordinary. From carrying rockets on bicycles in 19th and 60th century to the first country to land on Moon's South Pole in 2023. That is ISRO's story, that is India's story. If you are an engineering student watching this, or a science student, or maybe someone who had found this video by accident, I want you to know this. The people who built Chandrayaan-3 were not aliens, were not from different planets. They were engineers with degrees, who sat in classrooms, who failed in exams, who had bad days, who doubted themselves. They built something that no country had ever done before in the last 6,000 years of human history civilization. And the only difference between them and everyone else is they kept trying even after a mass failure of 2019. Because after 2019, ISRO did not ask how do we feel better about what had happened. They asked what exactly went wrong and how do we fix it so that it never happens again. That question, that way of responding to failure is the most important engineering lesson in the entire video. If this video gave you something that you didn't have before, then I would love to know that. Because every week I'll come up with a new piece of technology or science and explain exactly in this way, deeply, clearly and honestly. And if you want to watch UPI video I have made talking about how India had also built the world's most used payment system, the link is right here. That being said, I am Satyajit signing off. See you on the next one.